Question number 22. Question number 22 is, in question number 22, a pipe bend is given and we are asked to find out the reactions Rx and Ry, that means resultant of these two, right? So suppose velocity is entering, fluid is entering here with velocity v1 and leaving here with velocity v2, right? And we are asked to find out these forces. So first we will find out what are the value of these velocities, right? So velocity is how much? V1 is 4q by pi d1 square, right? Q is given in the question as 0.45 divided by pi. What is the value of d1? d1 is 500 mm, 0.5 square. So the value of velocity will come out to be, value of velocity will v1 will be 2.292 meter per second. Similarly, we can find out the value of v2. v2 will come out to be 4q by pi d2 square. d2 is cross section area here, which is 250 mm. So this will be 4q is 0.45 into pi 0.25 square, and this v2 will come out to be 9.167 meter per second, right? So velocity is known, right? Now to find out these reactions, we have to use this relation. Net force equals to momentum out minus momentum in, right? Now first we have to use this relation in x direction, right? So what are the forces? Forces will be pressure force, gravity force, right? And these reaction forces. What will be the pressure force in x direction? Here this will be P1 into A1, right? So P1 into A1, and the direction is this. Suppose this is positive x direction and this is positive y. So this pressure force is in positive x direction. Here pressure force will be P2 A2 cos theta. Theta is 45 degree. See, P2 A2 and this it makes angle 45 degree with the horizontal. So the component in the horizontal direction will be cos theta. Instead of theta we can write 45 degree, and the direction will be negative x, so minus, right? And this reaction you can assume in any arbitrary direction. We have assumed in negative direction, you can assume in positive x direction. So it will be minus Rx. This is net pressure force, right, in x direction. That is equal to momentum out, mass flow rate V2. This is momentum out. The component in the x direction, that will be cos 45, right? Momentum out minus momentum in, mass flow rate into V1, right? So here we can find out the value of Rx. The only unknown is Rx because it is we are dealing with water as a fluid, right? So P1 is given. P1 is 40 kilopascal. So it will be 40 kilopascals. A1 we can calculate since diameter is given. So we can find out the value of A1. Minus P2, value of P2 is into A2 cos 45 is 1 by root 2. Minus Rx. Rx is unknown. Mass flow rate we can take common, and that will be rho into Q, and rho and Q both are given. So V2 cos 45 is root 2 minus V1, both are given. So everything is given except this Rx. So the moment you will calculate the value of Rx, it will come out to be this, right? So this will be the value of Rx, right? We have found out the value of Rx. Similarly, we can find out the value of Ry, right? So now we have to use this relation in the y direction. If we use this equation in the y direction, see, there is no pressure force here in the y direction. Here it will be minus P2 A2 sine 45 degree, right? So this is pressure force, vertical component will be in the downward direction, this direction. So this is negative y direction, so minus, and then plus Ry, reaction force. See, this weight of the fluid will also be acting downward, but since in the question they have not talked about this volume or weight of the fluid in this bend, so we will neglect that weight of the fluid. Otherwise we have to consider if this volume is given in the question, right? Or this bend is, we can neglect weight when this bend is in the horizontal plane, then also we can neglect the weight. But since in the question weight is not mentioned, so we are not considering that weight. Equals to momentum out. So momentum out will be m dot v2 sine 45 degree, right? This is momentum out in vertically upward direction, so it will be in positive x direction, minus momentum in is 0. So when you will solve this, you are going to get value of Ry, and value of Ry is 3277.9 newtons. If you find out the resultant, that resultant is going to be under root Rx square plus Ry square. Both Rx and Ry is given, so the value of resultant force will be 6360.48 newtons. So the closest answer is closest option is D. So the correct answer will be D.